So in these examples, we're going to use those techniques we just used from factoring, those factoring methods, and we're going to use them to solve equations so that we can find the x-intercepts, otherwise known as roots. So we're going to use a zero product property that we learned when we did quadratics to set them equal to 0 and sort of correlate what we have in the problem and try to figure out which factoring technique is presented to us. So I zeroed this side out because we always want to maintain the lead coefficient to be positive. That has not changed in our technique. And then I'm going to write it in order from greatest to least exponent. And we now have a equation set equal to 0. And we can see that there are 4 terms. And so 4 terms is an easy way to know that we're going to be grouping this. Make sure you keep the sign on the second half of the problem. You're going to factor out here a common factor of x squared. And if you divide x cubed by x squared, you get x. 2x squared divided by x squared, you get 2. And then over here, it looks like there's nothing, but you have to take something out. And the minimum number you have to take out during grouping is 1, or in this case, -1. So if we divide negative x by -1, we get x, and negative 2 divided by -1, we get 2. So we end up with a factorization that is in common of x plus 2. And then when you remove that factorization, you have x squared minus 1. Now keep in mind, we're not just factoring. Remember, the purpose of factoring is to either divide, which we're not doing, or solve, which is what we are doing. These are the only 2 reasons you would ever factor. So now we realize that we're setting it equal to 0. We could use a zero product property, but this will factor again. So it's always helpful to get all of your factors lined up. This is what's known as a complete factorization. That terminology is used quite frequently on standardized tests. So this factors very easily into plus and minus 1. The factors of 1 that subtract a 1 are 1 minus 1. And now I use the zero product property. I know that zero product property said a times b equals 0, so a or b equals 0, but same thing with if there are 3. So you would set these equal to 0, all of them separately, as 3 separate little, like algebra 1-ish problems. And then you would solve them off. This one yields a root of x equals -2. This one yields a root of x equals -1. And this one yields a root of x equals 1. If we go all the way back to the very first thing we learned, we can put these in a set in order, -2, -1, 1, so that we know the set, the domain of the answers. All right, so let's take a look at the second one. And it's kind of interesting because you might look at it like, oh, that must be grouping. That is why you must use a zero product property to start. You want to set it equal to 0 and collect your terms and see what you end up with, because it may look like grouping, but we don't know what it is until we have collected our terms and zeroed out a part of the equation. So here we have x to the 4th. 2x squared minus x squared is x squared. And then minus 20, and we see, oh, it's actually 3 terms. It's not 4. So it's not grouping. Grouping is with 4. Later you can learn that you can also use it with 6 or 8 terms, but in Algebra 2 we just do 4. So 3 terms, trinomial, that is the quadratic method. All right, so the quadratic method in this case is telling us to lock in the x to the 4th power. That's why we had to have a square there, because it's going to take x squared times x squared to get x to the 4th. And then we need a -20 here, so that's telling us to subtract numbers that are factors of 20. And I'm going to try 4 and 5. Those are factors of 20. Oops, yeah, that's right. We're going to put them here and here. My apologies. All right, so now the question is what do those factors make? Well, it just kind of helps actually go through the math, right? So 4 times x squared is 4x squared. And 5 times x squared is 5x squared. So now we have everything we need in the factorization, but we need to get +1. And we know that we get to subtract, so we're clearly going to subtract that term, which makes this negative, which gives us the like terms here of positive x squared. So now we have everything we need for our factorization. X squared plus 5 down the column, and on the top, the row, we have x squared minus 4. And so, oh, I can factor that again, but I can't factor this again. So we'll have to talk about what that means in terms of solving. So this one will factor into x plus 2, x minus 2. Students always ask me, how do you know if it factors? Okay, when you have quadratics, it only factors if it's a difference. It never factors if it's a sum, like it would with a cube graph. So that's just 2 minus 2 is 0, and then we use the zero product property on all of these. We just have to pay a little more attention to this first one when we solve it. So when I take a look at this, these two are easy. Let's just solve them. X equals -2 and x equals 2. And so over here, we would subtract 5. So we get x squared is equal to -5. This is, if you remember the quadratic chapter, this has no bx term. So we're going to use the square root method. So I square root both sides, having a plus or minus. And so x would be equal to plus or minus the square root of -5, which is I root 5. So the question is, how do we organize these? Well, technically, you would need to say real solutions, right? We learned this earlier in the chapter. There are -2 and 2 in order. And there are complex or imaginary solutions. And those solutions are, if you want to put them in order, -I root 5. Oops, forgot to put the I in there. So -I root 5 and I root 5, and you can see clearly from what we learned earlier in the polynomials chapter, this is a 4th degree polynomial, so it should have 4 answers, including multiplicity and imaginary. So there are 2 real and 2 imaginary. Now you understand why I said those imaginaries always come in pairs. And if we go back and even look at the last example, there are 3 answers because it is a cube. So this one, guess what? It's going to have 3 answers. There might be some imaginary, it might be some real. So let's start by subtracting the 27 on both sides. Let's see what ends up happening here. Oh, we have the cube rule, right? All right, so this is 2x times 2x times 2x, and this is 3 times 3 times 3. And again, the framework is super important here. So the framework is parentheses, 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 minus parentheses. Why? Because when, got to do the SOAP. So the SOAP says same sign, opposite sign, and then always positive sign. So over here, we have a parentheses and a square, and then the opposite sign, started with a minus, so it'll be a plus, and then a product of A and B, and then always positive, and then a squared at the end. And so now I'm just going to put those numbers in here. So this will be 2x. This will be 3. This will be 2x. Notice how important that parentheses is. This will be 4x squared. So then I have 2x and 3 again, and then 3 squared. And this actually equals 0 because we're solving. So we'll put that in right here because think of this as just the factoring step. So we end up getting 2x minus 3, and then 4x squared plus 6x plus 9. So this will never factor again. It looks like it does, but it does not. But this easily solves. We can easily solve this. This is just 2x minus 3 is equal to 0. So we add 3, and then we divide by 2. And so our first answer that is real is 3/2. And what ends up happening on the other side is we have to think about our quadratic solving techniques. So there are 3 things. It does not factor. So we could either use completing the square, but that would mean we'd have to take a 4 out of a 6, which is not friendly. So we're going to be using the quadratic formula. So let's see what ends up happening with this. See if we get a real or imaginary solution. So here we would have 6 squared minus 4 times 4 times 9. So we end up getting 36. And then we have to subtract 4 times 4, which is 16, and 16 times 9 is 144. And if we take 36 and subtract 144, we get negative 108. So that's going to tell us, remember the concept here from the quadratic chapter. This tells me that I have 2 imaginary or complex answers. And that nice thing about math is math always makes sense in the long term. So we talked about the idea that this is going to have 3 answers. there's one real answer. So remember that complex comes in pairs, so there's going to be two complex answers when we do the quadratic formula. So to do the quadratic formula, we're going to do x is equal to minus b, so minus 6, plus or minus the square root of negative 108. So maybe we should take a second and break that down so we can just make our steps easier, right? So it's always good. It's supposed to be a 5. Came out weird looking. It's always a good idea to just break our stuff down as we go so that we don't just end up with a huge mess, right? So this is 2 and 27, and then 3 and 9, and 3 and 3. So this will be 2 times 3 root 3, or 6, but there's a negative on there, so that's an I. So it's going to come out to 6I root 3. Again, 2 times 3, root 3, and then divided by 2a, which would be 2 times 4, or 8. And then we're going to break that down by factoring out a common 2 in the top, so I can take out a 2 in the top, which gives me negative 3 plus or minus 3i root 3. And on the bottom, I have 2 times 4, and the 2's cancel. And that gives me my two imaginary answers. So it's kind of interesting, and you might want to get used to writing this. The 4 will divide on each part, so it's a good idea to get used to this alternate answer, which occurs quite frequently on standardized tests, where instead of just writing the 4 over 1, a big thing, they write it over both. So here are my two complex answers, and here is my one real answer, and that is the fundamental theorem of algebra, that including duplicates and or imaginary or complex answers, if the sum of the answers equals to the degree. All right, I hope you enjoyed seeing how to factor and solve polynomials. There's more to come in the next video.